Hi guys. So this is Dr. Mata speaking. We're gonna do a new video today. We're gonna start talking about transformations on exponential transformations. So actually, why transformations are important? Because it introduces modeling. So if we know how an exponential will change after we do something to that function, then we can more easily think, okay, what would be the function for this graph? So here we have actually, three different things, but all of them are functions. Functions can be written as just functions the way we're used to, like equations, right? Kind of, right? We can do a graph of them, or we can do tables of them, right? So these are functions. These are functions. These are functions. Just the way we show them is different, right? So this activity is how to pair these functions here with the corresponding graph. So what's the match? What match with what? So is this going to match with this? Is this going to match with this? And also the table. So we can have actually three matches: one with the written equation, one with the graph, and one with the table. Okay. So to understand how to do this, we have to actually understand how exponential work. Okay. So first of all, I want to show you the most important thing, that it's you have to learn how to distinguish growth from decay. Okay, growth, both of them are exponentials. Okay, all of them are exponentials. Okay, growth is when the exponential begins in a low number and starts increasing. Okay, when we say on a low number starts increasing, we think about y. Y is increasing. While x increases, y increases really fast. While decay would be we start at the really high value and then it decays. Okay, that's more beautiful than this one actually. So growth, when we increase the x, the y increases really fast. Decay, when we increase the x, the y, the value of y decreases. Okay, so as we know that, we can distinguish, is this grow or decay? Mick is here. What are you doing, Mick? You have to pay attention, Mick. Oh, I'm sorry. So okay, so is this a growth or a decay? It starts here, low number, and it goes really far up. So this is going to be growth, right? What about this one? This starts really at a high value and it goes down. This would be decay, right? Okay. Now, as you can see, there's a symmetry here. This is the same thing, but you see that? See the symmetry here, guys? This is actually a growth exponential multiplied times negative. When we multiply a function times negative, this function is going to flip around the x-axis. Okay? The same with this. Okay? So, okay, this is actually not an exponential, right? This is just a system of equations. So, okay, so now let's think about how to do this using Desmos. Let's see if we can turn this on. Here we go. So here we have this exponential that it's 2 to the x, as you can see, and we see how this behaves. Look, I'm gonna do something to this function to see what happens. If I add 1 to this exponential, what happens? You compare with the last one. Now all this exponential has gone up. Imagine, for example, that I subtract 1, see, it has gone down, right? So this, if we have a number adding or subtracting to the exponential, it's going to make the exponential go up or down, okay? Another transformation that we can apply, it's a negative on the exponent. If we apply a negative on the exponent, instead of growth, all of a sudden we have decay. So a negative here switches from growth to decay, okay? Another way to do this actually is, and I'm going to write exactly the same thing I have above in a very different thing. Sorry here. So to the power of x. If I do 1/2 to the power, of the power of x here. If you see, I have exactly this and this are exactly the same function. One is green and the other one is red. It's exactly the same function. Okay. Why is this? Well, if you remember the rule that we did a few days before, we have this rule here. X to the negative n equals 1 over x to the n. This rule here is the same one I'm applying in here. That's why they're the same. Okay? Okay, so what we can say is if we put a fractional, or let's say if the base is less than 1, if between 0 and 1, if the base is between 0 and 1, we're going to have a decay. If the base is above 1 and the exponent is positive, then we're going to have growth. Okay? Okay, and the last thing I would like to show you about transformation of exponentials is that if we time this, let's suppose that now we time 2 times to the x. Do you see where now the exponential is crossing the y-axis at 0, 2? What about if we put a 3 here? Look, goes to 3. What about if we put a 4 here? Right? Okay. So knowing this, what about if we change the base and we put here, let's say 6? It's still crossing at 4, right? Even if the base is different. So that means, knowing that, if I write, let's suppose I write y to the x equals a times b to the x plus c, and I ask you for this exponential, how much is a? Where a is going to be actually the crossing of the y-axis. So for this example, a is going to be 1, okay? And then how much is c? As you can see, c, right? If it's by the x-axis, as it is, c is going to be 0, okay? So right now we have y to the x equals, this is 1, so it's b to the x, and this is 0, so that's it. Now, after at 0 it's 1, but what happens at 1? At 1 it's 2, and then it's 4, and then it's 8. So it's being multiplied all the time times 2, right? So we have, it goes from 1 to 2 to 4 to 8 to 16. So we see here that the multiplier is 2 times 2. So that means that the base is going to be 2. So this is y to the x equals 2 to the x. So we know that this graph matches with this. Okay. Now here we have a decay, right? So, and we have, look, we have 1, 2, is it 2 or is it 1? Sorry, 3. This is 3. 1, 3, 9, right? So if it's a decay and it goes dividing, because or multiplying, depending how you see it. Now it's dividing because it goes that direction, so it's 9/3, right? Which is 3/3, which is 1, right? So this, it's 3 to the negative x. So this is gonna be actually this one here, okay? Here, okay, so look, here we can identify, we have a +1 here, so here we have a +1, right? And here we have a negative, which is flipping this, and this, if this would start at 0, this would be 1, and then 5, so it's this one, so this goes with this one, right? This one, 1, 4, right? So the base is 4. As it's negative, this one is this one, right? So it's pretty easy to identify. Then the same thing with the tables. The tables, if we look at it, we have to find a multiplying factor. So here from 2 to 4, 4 to away, right? 16, 32. So this is a multiplying 2. But you see this when it's 0, it's 2, so that means that the beginning, so for this one here, as 0 is 2, that means that if we have yx a times b to the x plus c, right? B, it's going to be 2 because it's the multiplier. But then as the beginning starts with a 2, that means that it's a multiplying 2, right? Let's see if it's true. So for 0 would be 2. For 1, 2 to the first power, yes, yeah, so that's correct. So this should be this. So this is 2 times 2 to the x, okay? Here we see that the multiplier is 4, right? 4. And for 0 is 1/16. So what we have here is a is going to be 1/16. So you're going to have 1/16 times 4 to the x, right? And like this. So yeah, so once you get used to it, it's easier as what it looks, okay? Okay guys, I hope it helps. Bye.